Hi everyone and welcome to another 3D revolution. In the last episode of my Eco 3D printing series, I took a look at which of the traditional 3D printing filament materials is the most environmentally friendly and what other options are available to make that even more so. In this episode, however, I'm going to be going one step further and delving into the exciting world of truly biodegradable 3D printing filaments. So let's have a look. In the last episode, I explained that of the popular materials for FDM printers, PLA is by far the most environmentally friendly. However, even though it's technically compostable, it does really need an industrial composter. And even then, it can take months, if not years, to fully decompose. If you're looking at disposing of a lot of filament, this could be a better option than for something like ABS or PETG, but it could always be better. Introducing biodegradable filaments. These filaments are classified as truly biodegradable, and not only are they produced from organic renewable resources, they are able to completely break down under the right composting conditions in a third of the time it takes PLA. In fact, both of the biodegradable materials I have here actually contain PLA, which means that they can print and perform in a similar manner, but the other ingredients make them far better for composting and for the environment in general. The first of the two I have here is ALGA, an algae-derived filament from US-based 3D Print Life. Whilst you might imagine that as a unique product, the price would reflect that, but these 1 kilo reels come in at around $35 US, which is at the higher end of the average price range for a decent reel of filament, and they come in a range of colours. The texture is said to resemble something like sandstone or bone or even wood, which could be a really cool effect with the right model. Not only does this promise to look good and perform similar to standard PLA, it also meets the ASTM D6400 standards for biodegradability. ASTM D6400 is an internationally recognized standard which dictates what is suitable for aerobically composting in both municipal and industrial composters. What this means is, although you'll want to check with your local facility, you should be able to recycle this filament with your food waste to be sent to a large composting facility, and that is really game-changing. The other biodegradable filament I have here is by one of the most internationally popular filament suppliers, Fillamentum, and is called NonOilen. Now, despite NonOilen printing at a colder temperature than standard PLA, somewhere between 175 and 195 degrees, it's actually got a higher temperature resistance after printing. A standard PLA has a temperature resistance of around 55 degrees, and even high temperature resistant PLA will start to soften and deform at around 85 degrees. However, after being printed, NonOilen has a heat resistance of 110 degrees without the need to anneal it, and that's really impressive. For me though, one of the real standout features of this filament is that it is certified safe for food contact and is suitable for being cleaned in a dishwasher. Not only can you send it to an industrial composter, but it will also completely biodegrade in an electric composter at home in just 3 months, which is a third of the time it would take PLA in perfect conditions. Now, whilst the algae filament is available in a range of colours, the NonOilen filament is only available in its natural off-white colour at the moment. I personally quite like it, providing you're not after a specific colour, but there's nothing to stop you post-processing it, but bear in mind that any paint you used may stop you being able to send it away for recycling. Both of these biodegradable filaments sound great on paper, but I'm sure you're wondering how they actually perform in real life. Well, in my next video, I'm going to be comparing both of these filaments in a series of performance tests, and they'll also be pitched against 2 more traditional 3D printing filaments, so make sure you keep an eye out for that. If you're interested in finding out more about PLA and other traditional 3D printing materials and what you can do to lessen their environmental impact, make sure you check out my last video that was all about that. If you've got any thoughts, comments or ideas, as always, pop them in the comments below. Otherwise, don't forget to like and subscribe, and I'll see you guys next time. Thanks very much.